Welcome everyone. We are discussing circles. Today I discuss some problems using condition of tangency. So two circles, look, two circles. This is one circle and this is another circle. Look. They touch each other externally at the point P. Then C1, C2 equals to distance between their center equals to R1 radius of first circle and R2 radius of second circle. So what is the condition? If two circles touch each other, then distance between their center equals to sum of radii. This is result of class 10. Now, for the second figure, this is figure 1. For the second figure, two circles touch internally at P. Now here, C1P, this is R1 minus C2P, R2 equals to C1, C2. So, two circles touch internally if distance between their centers equals to difference of radii. So, this is our working tool. Using this theory, we solve some problems. Now, problem numbers 1 and 2. So, problem number 1. Prove that the circles touch each other externally. So, you have to find center and radii of the circle. Now, for the first circle, what is center? C1 equals to 2, minus 3. Minus 4, so divide by 2, change the sign. And what is R1? R1 is G square plus F square minus C. So 4 plus 9 minus 8. So this is root 5. And C2, center of second circle. This is 5, 3. 5, 3. Minus 10 this. And what is R2? G square. So 25 plus 9 minus 14. So C is 14. So minus 14. So 34 minus this. This is 20. Root over 20. That is 2 root 5. 2 root 5. So we are getting center and radii. Now distance between center C1, C2 equals to root over 5 minus 3 whole square. 3 plus 3 whole square. 5 minus 3, difference of ordinate. So this is 4 and this is 36. This is 40. 40. Root over 40. 4 plus 36. 40. So 4 into 4 into 10. Now look. C1, C2, distance between their center, this is 5 minus 2 whole square, not 5 minus 3, 5 minus 2 whole square. So this is 9. So this is root over 45 equals to 9 into 5, so 3 root 5. Now look, sum of radii, so R1 plus R2 equals to root 5 plus 2 root 5. equals to 3 root 5. So this is C1, C2. Sum of radii equals to distance between their center. So therefore, two circles touch each other externally. So you need how to find center and radius. The result of class 10. So very simple problem. Now problem number 2. Examination. So prove that the circles this and this touch internally and find point of contact. Find also point of contact, that is coordinate of P. So what is C1? C1 is 4, 2. And what is R1? Radius G square, 16 plus 4 minus 16. So this is 2. R1 is 2. 16, 4, 2. So 16 plus 4 minus. So this one is not minus 16. This is plus 16. G square plus G square plus H square minus C. So minus minus plus. So this is 6. Sorry. Now C2 is, this is 1 comma minus 2. 1 comma minus 2. Now what is R2? 1 plus 4 minus 4. This is 1. 1 plus 4. This is C is 4. So minus 4. So this is 1. Now C1, C2, distance between their center, 4 minus 1 whole square, 2 plus 2 whole square. So this is 5. So we are getting R1 minus R2 equals to 6 minus 1 equals to 5 equals to C1, C2. So difference of radii equals to distance between the center. Therefore, two circles touch internally. Now, there is another part also, find point of contact. That is, you have to find coordinate of P. Now, look, figure will be internal. This is C1. This one is C2. And this is P. So look, we know coordinate of C1. This is 4, 2. Coordinate of C2, 1 minus 2. Now coordinate of P you have to find. Now C1, C2 is 5. And C2P, that is radius of second circle, is 1. C2P is 1. So look, here C1P equals to C1, C2 plus this equals to 6, or radius of the first circle, and C2P equals to 1. So P divides, here you have to find coordinate of P. So P P divides C1, C2 externally in the ratio. So C1P, this is 6. 6 is to 1. So what is x? mx2 plus mx2 minus nx1 by m minus n. External division. So 6 minus 1. So 6 into x2. What is x2? This is 1. 6 into 1 minus 1 into 4. 1 into 4. 6 into x coordinate 1 and 1 into 4 by 6 minus 1. So 2 by 5. 4 and y equals to my2 minus ny1 by m minus n. So this is 6 minus 1. So 6 into minus 2 minus 1 into, this is 2. So minus 12 minus 2. So minus 14 by 5. So coordinate of P will be 2 by 5 minus 14 by 5. So section formula. So you need only the condition of tangency. So two circles touch each other externally. Condition is C1, C2 equals to R1 plus R2. Next, problem number 3. Now we consider problem number 3. If the circles this and this touch each other, then prove that 1 by a square plus 1 by b square equals to 1 by c. So we need coordinate of center and radius. Now for the first circle C1 equals to minus a 0. 2ax, no y. That is why y coordinate is 0. R1 equals to g square plus f square. So this is a square minus c. And C2 minus b 0. R2 is root over b square minus c. So what is C1, C2? Distance between their center. So sorry, this is 0 minus b. So 2by 0 minus b. So C1, C2 equals to a square plus b square. So these are our working material. Since circles touch each other, therefore C1, C2 equals to R1 plus minus R2. Plus for if they touch externally and minus for internally. So root over a square plus b square equals to R1 root over a square minus c root over b square minus c. So we are getting this relation. Now simplify it. Squaring both sides. A square plus b square equals to a square minus c, b square minus c. A square minus c plus b square minus c plus minus 2 into root over a square minus c root over b square minus c. Squaring both sides. Now look, a square, b square cancel out. This is minus c, this is minus c. So 2c equals to plus minus 2 into a square minus c and b square minus c. You can take it within one root since both are positive. So 2 cancel out. Now taking squaring again. So c square equals to a square minus c and this is b square minus c. Plus square also plus, minus square also plus. So finally we are getting c square equals to a square b square c b square c a square plus c square. So c square cancel out. Now finally we are getting simplified form, no root. So a square b square equals to cb square plus c a square. So this is our condition. Now look at the form of proof. This is not in this form. So to get form, this form, divide throughout by a square b square into c. Dividing by a square b square into c. So a square b square cancel. 1 by c equals to 1 by a square plus 1 by b square. So this is the required condition. In competitive exam, only the 4 options will be given. So here it is given in proof form. So today I have solved 3 problems of circle using condition of if 2 circles touch externally and 2 circles touch internally, using condition of internal touch and external touch. So these are very simple and important problems. So thank you for today.